Welcome back to the FreeCodeCamp podcast, your source for raw, unedited interviews with developers. Today, we're talking with Tai Groot. He's a backend software engineer, and he runs an open source project used by companies like Google. For the first half of the interview, we talk about backend programming languages like Go, Rust, and TypeScript. Then Tai shares tips for learning backend development and running your own developer consultancy. Tai Groot, welcome to the FreeCodeCamp podcast.
Thanks for having me.
Yeah, and it's a sunny day there in Northern California, where you're based, near the software development mecca, somewhere between San Jose and San Francisco. And we're thrilled to have you here on the podcast.
Yeah, thanks for having me. It's exciting.
Yeah, well, I want to start with a question. You're a back-end engineer primarily. I mean, you can do everything, but like that's where you've chosen to specialize for the past few years. And a lot of people, when they're doing back-end development, they may be thinking, oh, I'll just use Python. I mean, you can use Python for everything, right? Why not just use Python for everything?
Yeah, it's a great question. So I did just publish a course that talks about the relative strengths of Go and TypeScript versus Rust. Python's another one of those options, right? So Python was actually one of my first backend languages, and it was a good time. I like Python better now than I did back when I used it. But yeah, I mean, there's plenty of reasons. Let's get into it. So Python is fine as like a glue language, I think. I would recommend it to a lot of people, depending on the situation. Tends to struggle with loops. So people that are learning Python for the first time, or people that are evaluating Python as like a main language, may not realize just how much slower Python is compared to a compiled language. And sometimes that trade-off is fine, right? Sometimes getting the ability to run through something like a Jupyter Notebook kernel, and being able to execute code top to bottom and then pause it and then have the ability to like fork your state and replace everything as is and make small little tweaks and changes and keep everything kind of frozen in memory and work off of like a snapshot of the heap. Sometimes that can be way more important than speed. So an example where that comes into mind is, machine learning, right? When you're doing machine learning and you're testing something out for the first time, and maybe it took you 2 or 3 weeks of crunching numbers to get to the point where you are now, and you need to do an experiment. In Python, you can literally set a breakpoint and pause the execution of the entire interpreter. You can dump everything to the disk and restore later using something like it's a pickle and shelve, I think, are the two that most people use. You can do all sorts of like really nice things. The developer ergonomics on Python have gotten a lot better than they have been, back when I was using it. Things like type annotations, and yeah, Python's come a long way. I started using Python, I believe, back on Python 2.7, and I only ever ended up moving away from Python because the roles that I had were primarily Go roles. So Go was like the new kid on the block. I've been hearing about it for a while. I mean, relatively speaking, it wasn't that new, but it's.
Yeah, Go is like a programming language, I think, developed by Google for like high concurrency and just like being really performant, is my understanding. That was like the primary thing that they optimized for. Is that accurate?
Yeah. So Go is a compiled language. So there's the runtime overhead is relatively low. Now it still is multi-threaded, and it has a garbage collector. And when I say multi-threaded, there's both threads and something that they have internally called Go routines, which are more like green threads. So your program may only be quote unquote single threaded, but you'll still have like a secondary operating system thread for running garbage collection and other things like that. So Go at least, the official statement is that Go was initially developed while a C++ code base was compiling. Like it was 100% of the Go original, 1.0 or the early tag release of Go was developed like while the developers at Google were waiting on downtime for a C++ code base to compile. I think it was Chromium or something.
Okay, so just to
And
put that in context, like, so for people that have just been working with like high-level scripting languages and just taken for granted that, like, that they don't need to have like a compile step before they can actually see whether their code works. Right? They could just run it real quick. You can see there's like I think it's like an XKCD where they're like playing swords on the swivel chairs. Code's compiling. Like their boss comes by. Why are you goofing off? Oh, the code's compiling. We can't do anything. I guess I'll just have to like sword fight because the code's compiling. We're blocked. But so in the time that their code base was compiling, they were like, okay, let's switch your context and let's go develop an entire different programming language because we have time while this slow compilation process unfolds. So that's what you're telling me.
Yeah, so I mean, let's talk a little bit more about that if you want. We can talk about the just-in-time compilation, which so all code is compiled before it is run, right? So Python being an interpreted language, there's no traditional compile step where you take Python code and turn it into an executable that a .exe or nothing runnable that you'd install on Mac OS or Linux as well. But every line is being compiled, and then there's some caching and other dynamics you can get into. But every line is being compiled basically as it's being run, like compile and then run, compile and run, compile and run. So it seems almost faster to just run Python, script.py and have it just execute almost immediately instead of having a compile step ahead of time. But that slowness of the compilation is happening line by line as it's running. So in some sense, you could kind of say like for a small enough Python script, it's actually faster to run Python than to build like a massive Go program or C++ program, because funny enough, you're kind of taking advantage of multi-threading almost, where you've got like a core that's busy running the Python interpreter, which is the just-in-time compilation step, and then another one that's actually running whatever C++ modules that Python is gluing together. Because that's another big point, is that most of the time when you have useful Python, you're not actually just running Python, you're running some sort of pre-compiled C++ object that's already been built for you. Whether that's like a web browser controller using something like as I think it's Puppeteer or Beautiful Soup, all these different libraries, especially anything that involves encryption or TLS, anything that's hitting a web server, you're always going to be running some sort of pre-compiled C++ object under the hood.
Yeah. Support for this podcast comes from a grant from Wix Studio. Wix Studio provides developers tools to rapidly build websites with everything out of the box, then extend, replace, and break boundaries with code. Learn more at wixstudio.com. Support also comes from the 11,189 kind folks who support Free Code Camp through a monthly donation. You can join these chill human beings and help our charity's mission by going to donate.freecodecamp.org. And it's worth noting that like Python itself and most scripting languages are originally, like if you go down far enough, it's C++, and below that it's C.
Yep.
And so what you're saying, if I can recap, this is actually new to me. I didn't realize this. So with an interpreting programming language like Python, it's essentially going in and compiling line by line so that you can skip that big upfront compilation step. It's just in time compiling. So if you have a small Python script that's only a few lines long, well, only those lines need to get compiled in, because you're able to take advantage of the multi-threaded nature of some of the underlying layers of abstraction. It can actually be faster for a small Python program. The fact that
it's gotta be really small.
Yeah. But the moment that your Python project gets bigger than like maybe a few little files, a few little scripts that you're running, you do start to pay that penalty for having just-in-time compilation, as opposed to having a compile step that you get with something like Go or something like Rust.
Yeah, and you'll see something very similar to that in JavaScript as well. So JavaScript is another interpreted language, famously so, right? It's the one that everyone uses for the browser. We've got WASM and a couple other things that are kind of emerging,
Yeah,
but we'll never get away
WebAssembly.
from JavaScript. Yeah, WebAssembly. Sorry.
Sorry, no,
Um,
it's okay. I didn't mean to interrupt you. I just love to
yeah,
share.
yeah,
Whatever, whenever somebody hears a term or an acronym, they may be familiar with WebAssembly and not know what WASM is.
yeah. So I mean, WebAssembly is emerging, but even WebAssembly requires like a JavaScript shim to get running. Like you have to inject it and start the runtime and pass data to and from the WASM or WebAssembly runtime. So we're never going to get away from JavaScript there. But so yeah, I mean, JavaScript being another interpreted language has something similar going on, right? So V8 is the most popular JavaScript engine,
Yeah, it's the
developed by
Google
Google.
Chrome kind of.
Yeah,
i- How would you describe it?
yeah, it's the JavaScript engine and runtime that's most people will see it bundled into Chrome, but it's also what powers Node.js,
Right.
and a couple other things. Um, so JavaScript has a couple of different modes of running, I guess. And so when you start interpreting a large JavaScript code base, it will just get basically JIT compiled or just in time compiled, just like Python, like top bottom. It doesn't have any optimization passes or anything like that. But V8 is intelligent enough to notice when certain functions or certain loops start to get called repeatedly, very quickly next to each other, like high repetition, and it realizes there's some heuristics built into V8 where it will notice, like, hey, I've JIT compiled this like 3 times now, 5 times now, 15 times now, um, and it will actually cache the compilation output of those lines. So when it finds those lines of JavaScript in the future, it will just jump directly to the precompiled set. So going back to what I was talking about with Python, it's one of those trade-offs where for a short enough program or a program that you're only going to use once or twice, doing something that's like interpreted or just-in-time compilation can actually be faster than sitting there and pre-compiling the entire thing. And the proof of that is every time you load a web page, the interactivity, if the web page is built correctly, the interactivity loads basically instantly. And it would take much longer if you were waiting for a pre-compilation step.
Yeah. Okay. So I'm going to recap some of what you said. First of all, JIT compile just in time, just like just in time production. If you're familiar with like manufacturing or something like that, you order a part and they custom, make it just as a one-time part, as opposed to having like an entire production run, create hundreds of parts, hundreds of copies of that part. It's like, here's that one part that you needed. So that's where the term just in time was imported for software development is from manufacturing. So just in time compilation, V8, this JavaScript engine, again maintained by Google, and I think used in Chrome, and of course notably used in Node.js, which the FreeCodeCamp curriculum uses as the primary way to like do full stack JavaScript. And of course the creator of Node.js also has Deno, which is basically like a kind of a SQL project that addresses some of the shortcomings of Node. But if you've heard of either of these projects, what's really powering them is V8. And the true power of V8 is, as you said, the ability to notice repetition within a code base and just cache the output of that like function or of that loop, so that it doesn't need to keep running it over and over. And that's how it can be so high performance, even with an interpreted language like JavaScript. And Node.js is famously extremely high performance, which is surprising considering that it is based on an interpreted programming language. So let's talk a little bit about Go and Rust, and we can talk about TypeScript too, which is basically just JavaScript with types. That is a little, it's type safe JavaScript, so you don't, it just dramatically reduces the likelihood of bugs. Type based bugs, my understanding, are extremely common. And it's one of the most common kind of things that can go wrong. So if somebody threw up their hands and said, JavaScript should just have static types, what the heck? And so they created TypeScript. But if you know JavaScript, you can very quickly learn TypeScript. They're practically the same thing. It's just, my understanding is it's just a little bit of additional functionality built on top of JavaScript. Is that Does that jive with what your understanding is?
Yeah. So there's kind of like a straight line that kind of goes from like your Python and your JavaScript languages through your Go language through to Rust, and it's kind of like a timeline in terms of how easy is it to write and versus how performant is it going to be, and also how long is it going to take to compile. So one of the kind of the through lines you'll notice is that the more performant a language is at runtime, usually the higher cost it has at compilation time. Um, so something like a C or a Rust are going to be around the same. C++, Rust, C++, C, and Rust are all going to be about the same. Now, C++ has just about the worst compilation time for a programming language that can build a program of sufficient difficulty or sufficient complexity. And that's because C++ really likes to import a lot of header files almost recursively, like over and over and over again. So really the problem with C++ compilation time there is not the code itself, it's more the header language, like the meta language, the macros that you can use up above that change the behavior of your code based on different compiler targets. Because you'll have library A that imports library B that imports library C that also imports library A, and you have like all these different like import cycles and everything. And see, the compiler needs to be able to handle that just because of so many years of legacy. And so that was part of why Go came into being. Was again the compilation time of C++ is so slow that they're like we need something that's faster to compile at least than this. And while we're building that, why don't we try to come up with a language specification that is going to give us a language that's really easy to write and it's really fast to onboard new developers too, while maintaining that we need to make it high performance at runtime, so we can't have another interpreted language. So Go kind of fits much closer to Rust than to TypeScript on that through line, and certainly much closer than Python. So starting back over at TypeScript and JavaScript, like I had said earlier, being interpreted languages, there's always going to be some sort of slowdown to that compared to a precompiled language. Now, like I said, there's a price you pay in compilation. That's a one-time cost that you pay for execution. So if you're going to execute this program twice, 3 times, 4 times, is stuff running in production? Is it running? Are we now talking? It's not just a shell script that runs top to bottom and then exits. Maybe it's a service that's running long term. Well, keep in mind that that cost is going to be accruing over the runtime of the program, not just a one-shot execution through func main or the main function. So a lot of the gains that you get are actually going to be towards more server-driven applications than for command line tools. There's a huge boon of command line tools that are written in Python and TypeScript, and they're all perfectly fine, right? They'll run through, and as a developer, you might be running it a couple dozen times a day. I think there's like some command line utilities for accessing AWS resources. I think the AWS CLI, I think that was originally written in JavaScript. It might be in another language now, but yeah, there's a lot of command line utility programs or CLIs will all be written in Python and JavaScript, just because the speed of execution isn't anywhere near as important as the developer's ability to make quick and easy changes to the code, or to test things using the like I said earlier with like the Jupyter Notebook kernels. You pause execution and do some more advanced debugging at runtime. Types added something really interesting to both Python and JavaScript as interpreted languages, because neither of them actually are used. And what do I mean by that? So in a language like C++ or Go, you've got, or especially Rust, you've got a type associated with every piece of data. And so every piece of data that you have has a shape to it that's part of that type. So if it's an int, like an integer type, you know exactly how many bits in memory or how many bytes in memory are going to be set aside for that type. And if you define a struct, or in Python, or in Python it would be a class. If you define a struct in Go or in Rust, you're going to be setting aside exactly the amount of space required for all the different properties within that class or within that struct. So if you've got two different numbers and then a string, like, you know the size of that struct. You know how big it's going to be. You know what it requires to fit that into memory, especially when you're fitting an array of them into memory, or a slice of them in Go in memory. So if you've got a bunch of them, you know exactly how to lay out your memory ahead of time. Now, in JavaScript and Python, you can't really do that, right?
Yeah, because of the duck typing. Like, so
Yeah.
you know, like a binary takes up the same amount of space in memory as, you know, I don't know what the large string is. Yeah. I mean, what would be the biggest? I just want to make sure I'm understanding you correctly, because I didn't realize that it was this inefficient. If I'm if I'm getting this correct, that it was this memory inefficient, having a duck typed language. And the reason it's called duck type is if it looks like a duck and quacks like a duck, it's a duck.
Then it's probably duck.
Basically, like dynamic typing, where you just say var equals XYZ, and then it stores whatever that is, and it doesn't care what type it is, whether it's a Boolean or whether it's a string or an int. It just sets that aside, and then it can be changed. It can change from one data type to another when you reassign it later. That's something that you can do with dynamic typing that you can't do with static typing, and that's what I said leads to a lot of type errors. But some creative programmers might be able to use that to do things efficiently, just to have this generic container that they can put whatever data they need into for the time being, and then they can overwrite it later. But but that comes at a cost in terms of memory, is what you're saying.
To your point, DHH loves that about Ruby. He said, there's some projects that are trying to add types to Ruby, and don't you've got a good thing, don't ruin it. He loves his dynamic typing, but yeah, and I mean, focusing on JavaScript for a moment, essentially every variable you ever create in JavaScript is going to be a pointer. It doesn't feel like a pointer, but it is, and it's a pointer to the piece of memory that's been allocated. But it's not just that. It's going to be like a struct. So you've got inside of your memory, you've got a pointer to the memory, and then you've got tags on it for when it was last used for the mark and sweep garbage collector, because it's also it's not just dynamic, it's also garbage collected. And then you've got the actual value, or potentially a pointer to the value if it's you know, another dynamic, if the value inside is also dynamically sized, like an object or an array. So you end up almost like ballooning the memory that's required. And there's been an optimization made in the I don't know how many years ago for small integers. So small integers and booleans, they use SMEs, which is like a small integer, SME. And so some variables don't actually take up all the memory that's required by like an object. Where you really get into trouble in JavaScript is when you start getting into functional programming, and you're doing like .map, .filter, .map, .filter, and you're constantly like every time you're calling a function off of an object in JavaScript, you're creating more memory.
Yeah. And that's something that you do all the time in JavaScript, because functional programming is the ideal way to use JavaScript.
Yeah, it's considered good practice to create tons and tons and tons of memory, especially memory that you're only ever going to use once in the middle of a function call chain, and then never again. And that's kind of wild, actually. But you know, the V8 team is really good at optimizing for that. Basically, the entire I can almost feel like a sigh of desperation from the V8 team every time like a new programming like kind of fad comes on, like on the JavaScript community, where it's like, okay, well, now we're gonna do we want to chain a bunch of operators. Now we want to there's a proposal that came through for adding the types from the TypeScript type system into the language itself, right? And it's just like, man, I'm very impressed by how well they've managed. I'm I also feel really sorry for the developers for all the different things they have to keep in their head in order to not just maintain specification compliance, but also to be performant enough that everyone can use all these crazy patterns and idioms like in a mobile browser on a cell phone.
Yeah.
Right. It's actually like V8 is probably one of the most impressive projects, like next to like the Linux kernel and Minix and a couple other big guys, right? Like it's certainly up there.
Yeah. Well, I'd like to talk more about maintaining open source because that is one of the things you do. You're an open source maintainer, and we're going to get to that in a moment. But I do want to just kind of like cap off our discussion of these different programming languages, specifically Rust, Go, and TypeScript. And maybe you could give like an ideal kind of use case for each of these ones and when it would make sense to use each. So I just want to kind of step back and give you a second to like think of like an example project where like, oh, this is definitely like a place where Rust would shine. This is a place where Go would shine. This is a place where TypeScript would shine. Just so everybody listening can walk away with kind of just like some kind of general vibe for where they can be when they're trying to decide which language to use for a new project.
Yeah. TypeScript is a good language for large teams that are potentially not all in the same time zone, not all working, in the same office. The speed of development of JavaScript plus the added safety of types, which are, will help you with autocomplete in your code editor and help you with making sure that you're not introducing new bugs and that you're using function calls and signatures correctly. That will allow you to have high speed and velocity in your team's development while also not making, clumsy mistakes like breaking function signatures and then the caller is not getting back what they expected. So JavaScript just being a really easy language to write code in, comparatively to Go and Rust. Really, the power of TypeScript comes from JavaScript being easy, but then you tack on just a tiny little bit of extra difficulty on top to maintain safety so that you don't run into runtime bugs. That's kind of where I would say like JavaScript is really good for like large teams or especially it's really good for teams that are writing a full stack application that's running both on the back end and the front end. So something like a web server with like a browser client. So for example, in React, the Next.js code base is written in TypeScript. And the reason why that's beneficial is you're writing a React app using Next.js, and you need to figure out how does this router actually work? I'm importing next/router or next/navigation. What is that code actually doing under the hood? You can go to definition and you can jump through and that's using the types and the imports in the type system. You can jump into the actual definition of that function and you can read it, and it's all in one language. So that's really helpful in terms of JavaScript and TypeScript. And I'm going to skip over Go for a second and go all the way to Rust.
And before we do, I have a very quick question. Would you consider creating a new project just in vanilla JavaScript, or would every JavaScript-related project you create going forward involve TypeScript?
If it was small enough, I might use JavaScript. So I have a Chrome extension or one or two Chrome extensions that I've published in the past. And there are less than 80 lines of code. And in fact, in the most recent version, I think using the .map and .filter that I was harping against 10 minutes ago, I got them down to about 13 lines of code or 8 lines of code.
Wow.
I'm not going to use TypeScript for something that small. There's no like the build step would take it would take longer for me to configure the build step than it would for me to just delete and rewrite the code. So in that case, I would use vanilla JavaScript. But for any sufficiently large project, especially any project that's running on the front end, I'm almost always going to be using TypeScript. Now, am I using TypeScript, directly, or am I using what's the other one where you can define your types in the comments? I'm forgetting the name right now.
I can't remember the name either.
Yeah, I can't remember the name.
There's a quick. I'm sorry. Go ahead.
Go ahead.
I was going to say I do need to do a quick disclosure. The FreeCodeCamp used to use just vanilla JavaScript, and we've since migrated fully to TypeScript. And the FreeCodeCamp core curriculum does have a section on TypeScript, and we recommend like learning it after you learn JavaScript, and then just never going back.
Yeah. The word I was forgetting was JSDoc. So there's a
JSDoc.
version, yeah, there's a version of TypeScript, and that's going to make some people mad that I described it that way. But there's a version of TypeScript. It's supported by TypeScript that you can define your types in the comments above and around a function instead of inline, which prevents you from having to do you don't have to strip the types out before you run it, which is, because JavaScript, all the JavaScript runtime engines don't actually support TypeScript. They only support JavaScript. So all the types have to be stripped away and basically just like delete the strings from the colons and everything. Like it, you can basically semantically, you're using like a grammar. You can remove all the different types and then just run the code as is. So skipping over Go and going from TypeScript to Rust, I recommend Rust for a couple of different reasons. So when you have something that is of high criticality in nature, so we're talking like a space shuttle launch, we're talking automotive, like, because
Safety, like
cars don't seem that serious until you realize
safety, or
physical human safety problems,
hundreds of millions of dollars in the case of sending up a satellite or something like that.
Yeah, exactly. And embedded as well. So Rust and Go, you're not really, with a small exception for TinyGo, I'll give TinyGo a shout out later. With a small exception for TinyGo, you can't really run JavaScript or Go on embedded hardware, and Rust has support for that. The Rust ecosystem is very interesting because if I were to draw a parallel to like kernels, like operating system kernels, that might be a little too in the weeds, but macOS famously has a microkernel architecture where a lot of the different things that were considered core system utilities, like when Windows was first released and other systems, Unix and Linux, they actually get moved out into system binaries that aren't running in kernel space, they're running in user space. And that's kind of how I view Rust a little bit. The core runtime for Rust is extremely small. There's almost nothing that I'm going to get in trouble so many times. There's almost nothing you can do with just the standard library in Rust. Even for just like async operations, you need to pull in a library. So you can pull in, and I think the most famous one is called Tokyo. And it's like, if you want async functionality in Rust and you actually want it to work, you've got to pull in a third-party package, right? So Rust has these things called crates, which is their version of a package, and there are a lot of crates. And I believe in the course that I put together, we built like a command line application that checks weather API and pulls, like, uses your location and pulls down the current temperature and humidity and a couple other weather related statistics. I think I had to pull in like 7 different crates because there's no JSON parsing built in. Like just things that you take for granted. Like JavaScript's got a way to parse JSON. It's JavaScript object notation. Go's got encoding/JSON, which is built into the standard library. With Rust, you need to pull in a package. And so that's a double-edged sword because you're not going to have this large overhead from like a standard library that gets built into every Rust binary. But you do have to pull down and depend on a lot of third-party libraries. And that feels really weird coming from as a Go developer, coming from the Go standpoint. Having to rely on a third-party library feels a little bit weird because in Go, a lot of these core things are built into the standard library, and they feel almost like blessed by the Go developers, right? So there are third-party JSON encoders and decoders in Go. They aren't part of the standard library. There is a standard library decoder, and that's considered like the canonical way to encode and decode JSON. Now, I think Uber has an open source project for encoding and decoding JSON very quickly. So I believe they're still standards compliant, but like the code that they wrote is doing some weird hacks, and it's not considered idiomatic. So people will typically end up using the standard library version, even knowing that it's a little bit slower. At least right now. That's another thing about Go, is that the Go team basically has this, I don't want to call it a guarantee, but almost like this and it has been spoken, so I can't call it a guarantee, and I can't call it an unspoken promise. It's not really a promise, but every new Go release that comes out is usually slightly faster than the one right before it. And if there's some sort of trade-off, they'll usually trade like using a little bit of extra memory for higher speed, because generally people care about their speed. Like when you look at like a data center or a cloud, like Go is very data center and server driven. Data centers are caring more about their compute costs than their memory costs in a lot of cases. Memory has gotten very cheap. Compute has gotten more and more expensive, especially as we're competing with, the Nvidias and the OpenAIs of the world.
Yeah.
I know that those are primarily GPU companies, but they're using up the same fabrication and the same fabrication capabilities.
Yeah. So just to be clear, like
they're still competing.
there are so many, silicon kind of foundries where they actually
Yep.
print the chips essentially.
Yep.
And if most of those are being used to print like ASICs and GPUs and stuff like that, it does ultimately reduce the total amount of compute being introduced into all these data centers around the world that is not dedicated toward massively parallel operations like powering an LLM and doing inference and stuff like that, or training or inference. So what you're saying is the Go team will usually just say, oh, memory is not the bottleneck here. It's actual like performance in terms of like how quickly an actual program gets executed. Am I accurately?
Yeah, and I hope, I mean that's what I said. I hope I'm not mischaracterizing the goals of the Go team here. I think I want to say they've been really good about memory as well. It's just that when there's a very clear optimization win for compute will usually win over memory, is what I've noticed, at least. And I could be incorrect on that, but that's what I've noticed over time.
Okay. And
so
that's like an organizational philosophy. Like they always want Go to be getting faster. Naturally, as they add more features, it is going to kind of slow stuff down. So they have to figure out ways to like further optimize what they have to compensate for the additional bulk that they're adding. Kind of like if you're trying to run like a really long race and you have to keep adding like additional limbs or something like muscle mass, you need to be sure that you're able to like still move that muscle mass even though you're bigger at least the same rate as you were doing before, ideally faster. So maybe you have to compensate, or maybe a rocket would be a better analogy. Like you're adding additional stuff to like you add more fuel to the rocket, but that also increases the weight, which means you have to add even more fuel, which adds even more weight. So you have to make sure that like the fuel you're adding is actually the rocket's still able to escape. I don't.
Yeah, exactly. I mean, Go binaries are very large compared to binaries in other languages because that standard library is so big. Because every time you build a Go binary, even if you're writing a very simple command line application, single threaded, top to bottom, 20 lines of code, you're still bundling the garbage collector, you're still bundling the runtime, you're still bundling, like there's like this fixed cost overhead that you have building with Go. So to wrap up why I think someone might pick Rust over Go or over JavaScript, I would say, again, the biggest reason I would recommend it would be for something that's human safety critical, or just safety critical, I suppose. The other good use for or embedded, the other good use for Rust is when you're doing a rewrite. So I personally will probably, well, at least I'll try, will never pick Rust as the language that I write a program in for the first time. Because a lot of the time when you're writing code in any language, you are learning new things about the problem space as you're writing the code. And it becomes kind of like an evolution, I guess, of your code base over time as you are meeting your initial requirements and then realizing some of your initial requirements were wrong and throwing them away and coming up with new requirements. Or maybe you realize that two of your requirements are in conflict and you have to decide which one wins out. So there's code is rarely, if ever, written exactly as initially designed. There's almost always going to be some sort of change. And it doesn't matter how good your specification is. unless your specification is the code, because we have a word for a specification that is exactly, word for word exactly what you want. It's called code. Yeah.
Yes, and people misunderstand this all the time. I'm just going to take a moment to get on my soapbox. Okay. People think like, oh, I can just tell GPT what I need and it's going to write the code. Like if you tell GPT with the sufficient specificity, you are essentially writing that code yourself. And people who don't understand, like a lot of non-technical people don't understand that, like, if you want to sufficiently articulate what code is essentially just the tersest way of articulating what should happen. It's communicating to the computer. So sorry, I didn't mean to take you off, but I want to clarify
exactly where I was headed. Yeah. Exactly where I was headed on that. And so we have a history with all these different languages of putting all of the behavior into, well, or at least most of the behavior into the code itself, like the top-down control flow in the code. So we have, let me rephrase that. We have a history of having a problem that we need to solve, and then encoding that top down, left to right, top to bottom into a code base in terms of like statements that execute. And then there's exceptions to that with things like Lisp and other languages that aren't top down statements. They're whatever, but you get the point. You can still kind of read it left to right or right to left. There's exceptions to everything, but with Rust, it's kind of coming along and saying, okay, we're going to actually encode a significant chunk of the behavior of this code base into the type system. And when you have your behavior predefined, that's a really powerful thing, because you can't do X or Y with this struct, and you should never be able to. Well, the compiler will now prevent you from being able to do that. If for example, you've got a piece of memory, let's say, for example, you're writing a password manager and you want to make sure that this piece of memory is never accessed more than once, that's something that you can encode into the type system, and it will never be accessed more than once. The compiler won't let you build a program that tries to access it more than once. And then your requirements change and you realize, oh, well, actually, we need to require it once to display it and then another time to copy it to the user's clipboard. And now you have a decision. Are you going to rewrite your type, and it's going to affect all of the other, and in Rust, they'll call them traits, right? Not types. So sorry if I'm offending Rust developers out there, but you have a decision. Am I going to rewrite my trait or rewrite my type, or am I going to make an exception and create a brand new type just for this one use case and apply it just to this data type? So you end up with a lot of churn in a Rust code base when it is your first write through of the code base. And oftentimes it means like re-architecting or rewriting all of your code as opposed to a small piece of it. If you write the code base through and it's functional in another language first, you already have like a clear roadmap and a clear path on what it is you have to do. A subsequent rewrite in Rust can almost always give you benefits in terms of speed and clarity and even cut down on verbosity a little bit. Okay. So I would recommend Rust for rewrites as well.
Okay, so I just want to step back real quick and share, like, so first of all, I'm learning a tremendous amount. This has been awesome. So pretty much everything between Go and Rust and even TypeScript and Python, it comes down to like developer experience trade-off versus actual performance trade-off when you're actually running the application a whole lot of times. So if it's going to run a whole lot, then naturally the actual development process, the time that goes into writing it, is just a fraction of the consideration, probably. But if you're the only user and you're just writing a script that is just going to be run periodically and probably not use even a fraction of your system's memory when you're running it in the background, just for your command line interface script, like I have tons of those that I run throughout the day to get different things done, then it doesn't really matter. And developer experience is the most important thing, because you may need to go there and customize it and stuff like that. And then moving from, something like Python to Golang, or Go, as we've been calling it, but you'll also hear people say Golang. This is the same thing. Essentially, you're kind of moving on that spectrum of, like, the developer experience is slightly more constrained, but it's also a way faster. And then if you move way off to the other side of the spectrum, that's where you have Rust, where everything is, you're importing something and everything has to be like deliberated about beforehand. And that's where you said having like a sufficiently written spec code from your first version of the application that basically serves as your map for how you're going to actually write this code. So, and you've already maybe been running it for a while in production, and you already have a good idea of like this is more or less how it's going to be for some time. So you just want to rewrite it in Rust and make it a little bit faster, essentially, like use fewer resources, maybe make it like slightly safer and stuff like that. So again, you're moving down the developer experience to high performance spectrum, essentially, as you go. And I just want to make sure that my understanding of this is correct. Python would be at the far edge of that, the easiest to use, the best developer experience. And then, you'd have your TypeScript, and then you'd have your Golang, and then at the far edge, you'd have Rust. And of course, you can go even further down than Rust. But that's like as far as we're going to talk about in this podcast.
Yeah, exactly. Yeah. And of course, developer experience is there's also always going to be a subjective element to that. For me, the developer experience of Go is going to be easier than Python because that's the main language that I write in, right? And it's going to be different for somebody else. Someone else is does nothing but write Zig all day long. They're going to have an easier time writing Zig than they're going to have writing a sufficiently complicated Python program. So yeah, I mean, I would say that's perfectly characterized as what I was saying.
Awesome. All right. So just to recap what you're saying then for ideal projects, like let's say you have just a script with an audience of one, like you're just writing something only you are going to use, or you're making some random open source library that you're going to yeet onto GitHub, and maybe somebody will, use it themselves, but who cares? You're just moving on with your life. You're not planning to actively maintain this. Python might be a great thing, or if you're already familiar, just whatever tool you're most familiar with, you might write such a script in Go. And then Rust is really just for doing rewrites is the primary thing that you said. Like I know that the Linux kernel project, one of the most important and most sophisticated open source projects on earth, they recently started allowing, Rust for, I don't know the extent to which it was allowed in, but maybe, do you know very much about that? Can you talk about that?
I know an awful amount about that, unfortunately.
Okay.
Yeah, it's
give us the skinny.
It's full of drama. That's the short version. It's full of a lot of drama. It has been allowed into one subtree of the kernel for device drivers. And it's a situation where there have been there's first of all, there's a very successful project called Asahi Linux. That the goal of it was to get the Linux kernel ported to the M series MacBooks. And so there's a long saga of all the drivers and everything that were written for that project were all written in Rust. I think it was just after the announcement that Rust was under consideration for a language that would be allowed into the kernel. There has been a lot of drama over actually getting the patches that have already been written and are working accepted into the kernel. And not to both sides this too much, but there has been a lot of drama and unnecessary grief over the whole situation. There's maintainers that say, I don't want to maintain a code base that has two languages. I read and write both of these languages, and just the fact that I'm moving from the responsibilities of maintaining and authoring a one language code base to a two language code base sufficiently increases the difficulty of my role enough to the point at which it's not worth doing for me. So I quit. Like I'm out.
Wow, that's
it. And then yeah,
I mean, lots of code bases have multiple languages. I would say it's probably pretty
sure.
rare that, yeah.
Sure, but a compiled code base that has as many eyes on it as the Linux kernel, with as many paying corporations that are using it for everything and sponsoring and require high reliability. And we've had very recently a couple of things slip through all the way to release candidates that really shouldn't have. And
are you talking about like bad code, or are you talking about like attackers?
Bad code in the Linux kernel. So I mean, there's also very famously there was the XZ utilities stuff, but that's not really part of the Linux kernel, so that's not really what I'm talking about.
Okay.
But there's been stuff where Torvalds will receive a patch, or Greg KH will receive a patch. Those are the Greg KH is like the number 2 on the Linux kernel right now in terms of approving and releasing patches, and they'll receive a patch and they'll say this should never have even gotten close to making it to me. Like it should never have gotten this far. How come it slipped past so many layers of review? Now, to be totally fair, companies that develop, I believe like MediaTek and Broadcom and Intel and AMD and like a lot of chip makers will submit large patches to the Linux kernel even before their CPUs are released, just to make sure that they run day one in data centers and for consumers and everyone. And a lot of the time that's very obscure in an obtusely written code that Torvalds has admitted, like, yeah, I merged it and I have no idea what it does. I hope it works, but it's your tree branch, guys. Like it's your driver and it's your hardware, so it better work. So it's not like having obscure code merged into the kernel isn't a thing that happens. It's just not like, I think a lot of people are complaining about it because they don't understand the Rust code that's being written, or they disagree with the architecture of it, and they don't want their neck to be on the line for merging a bad pull request in.
Yeah, and I can imagine
there's a lot of drama over that.
I mean, device drivers, like, just for clarity, like things that you plug into your computer, essentially, whether that's a new like graphics card or whether that's a mouse, like everything has to interact somehow with the like at least indirectly with the kernel to actually work on a computer, right? So I can't imagine, like, you and I are open source maintainers. I just can't imagine the complexity that Linus Torvald and Greg Cage and like those people are dealing with. And it's got to be terrifying getting like a PR for, I don't know, thousands of lines of like C++ or something. Just be like, yeah, I guess.
Yeah, well, no C++ in the Linux kernel. That one's not allowed yet.
Oh, it isn't. Okay, what is?
No, it's just C.
It's just C.
Just
they don't even use C++.
No. Linus is ideologically opposed to C++ and for many reasons.
Okay.
What are mostly
some of the
just
reasons? Because is it memory safety or?
I think it's more the style of the language, because you have every possible feature in C++. Like C++ has every feature from every other language ever made. And that's a joke. There's no borrow checker from Rust in there or anything like that, except there's a new proposal out for something called Safe C++. So even if I try to make a joke about, C++ doesn't have X, it's like, well, actually, hang on. There is a way that it does implement that. With C, you basically end up arguing over variable names and indentation and maybe where you put your curly braces. There's not a whole lot of options for writing, C can only be written in a few different ways. In C++, you've got objects, you've got templates, you've got all sorts of different like patterns for writing code.
Yeah.
I probably don't even know a third of them.
Yeah, I know people that are C++ devs who feel like they still have a, fleeting grasp on the language.
Yeah. So, yeah, he's very, very opposed to that in the kernel. So it's just Rust and C, and then I think there's inline assembly in a few places as well, especially for the cryptography libraries.
So that's the main source of the drama, is just people don't want to have to like learn a second language or maintain it. Like, and so essentially my understanding is they were like, okay, we're accepting, Rust contributions to the kernel. And then they realized, oh damn, like a lot of people, like, so there are a lot of work that's already been done that's waiting to get merged, and people are feeling like they got bait and switched.
Yeah. A lot of it is, I wouldn't say it's just not wanting to learn the language. A lot of people are afraid of how it's going to cause the Linux kernel to change, because people will depend. So there's a parallel tree for the Linux kernel as well that's like got all the Rust stuff implemented in C, because some people may not want to compile the Rust version of the kernel. I don't have cargo, or I don't have anything. I don't have the tool chain on my system. I'm not going to build that one. I want to stick to the tool chain that's always worked. I've got pipelines that run, like build pipelines and CI. You have
to maintain a parallel version.
There is a parallel version of the kernel that does not have any Rust. Now, I'm not saying that they're one-to-one feature, like one-to-one on all the features. They're supposed to be, from what I understand. And so that has also drawn some ire, because the people that are writing the Rust code will use a function or some functionality that can't be done in C. Or the people that are writing C will use something that would have to go into an unsafe block in Rust, which basically strips away all the memory protections from the borrow checker in Rust, which is something you have to do sometimes and probably more often than you'd want in Rust, but ideally you don't do that. And so there's just arguments on how things should be architected, because if you're going to write the same code base twice, maybe you should also architect it similarly so you don't have to context switch. You already have to context switch between languages. Now you got to context switch between architectures used within one language versus another. But if you don't do that, then you can't use the features of one language versus the other. So I think that's more of what the argument is about, the C maintainers and the Rust maintainers not agreeing on the way something should be done, rather than just it being two languages. But there was absolutely, on the mailing list, there was a fight that happened where a C maintainer left the project over not being able to, I don't want to say not being able to handle, because that's a little bit rude, not being able to, basically not being able to deal with having more than one language. So
and many of these contributors are just completely unpaid. Like, a lot of people probably get paid by a company. Like, I am, an open source contributor. Like, a lot of open source is actually funded by big technology companies who have devs who help maintain these open source projects. There are also a lot of volunteers out there. But this person, were they just like a pure volunteer when they left?
I'm not sure, actually, and they didn't leave Linux kernel development entirely. They just got removed from that group. So they moved. I don't even know if they moved to another group. I think they were maintaining multiple different groups within the Linux kernel, and then they left the device drivers tree.
Okay. Yeah. Interesting. Well, we could talk about this for a while. I've learned a tremendous amount so far. I want to get into more stuff. As I promised, in the intro that I haven't yet recorded, but I'm going to promise this in the intro that I'm recording, that we'll talk a whole bunch of technical stuff, and then we'll get into more general actionable tips for people who essentially want to get in the position that you are in. So let's start with the autobiographical background of you, Tai Groot. And yes, your last name is pronounced the same as the Guardians of the Galaxy tree-based life form.
Yep. Spelled the same way too. Yeah. Well, I mean, how far back do you want to go? So, I've been writing. Yeah.
13, I think, is when you started coding.
Well, so I guess my story would start when I was 8 years old. So I was originally I was 8 years old, but when I was 8, I was really into creative writing. And I really wanted to write a story. I wanted to write a book. But it just didn't seem right to me that I had to write it down on paper, and paper could be lost, and I couldn't make a copy of it without handwriting it over and over again. Surely there must be a better way. And my parents had an extra computer in a spare room that we had, and I basically just asked them, like, can I type my story into the computer, and then I can print it out on 2 pieces of paper instead of 1, so that I don't lose it. I'm not really thinking of files or anything, or like this is before flash drives were as ubiquitous as they are now. So it was just like, I can connect this to a printer, and I can print 2 copies of it, but I only have to write it once. So I was writing a story, and then, as children sometimes do, I decided, oh, you know what? I don't actually want this story to be about pirates. Now I want it to be about monsters or whatever. I was changing the story. And because it changed the story, I wanted to change the title, because the title didn't fit anymore. So I had seen my dad do this many times. I go to I hit the minimize button. I go to the desktop, and I rename the file, and I hit enter, and then my file doesn't open anymore. And I don't know why. And Microsoft Word, 2003, Microsoft Word 90, I don't remember what version of Word it was, just crashes. It doesn't open anymore. I can't open the file. I would always open my story by double clicking on the icon, and it didn't work anymore. So what I actually did was I didn't add .doc to the end. This is before docx. I didn't add doc to the end. And back then, Windows wasn't as hand-holdy as it is now, and it actually lets you rename the file extension without prompting you. So the association between that file and Word was broken. And if I tried to open it, it would open with Notepad, and you just see like a bunch of XML and not binary like ones and zeros, but like base 64 encoded, like jumbled high entropy characters just like all over the screen. And I'm 8. I don't know what I'm looking at. But that's kind of what hinted to me, like, oh, there might be more to a computer than just typing letters in and seeing, stuff on the screen. fast forward years later, I had a friend in middle school through high school. His name's Jonathan, or John, as I called him. His dad worked for a company that did a bunch of like very highly technical company. I'll leave it at that. And he was very into Python. So he kind of got me into Python. I remember a formative moment for me was he showed me like, oh yeah, by the way, we can write a virus in one line in Python. And like, I don't know what a virus is, but that sounds interesting. What is that? And he basically wrote like a fork bomb in Python and showed me how to write it.
A fork bomb is essentially like a procedure that just keeps copying itself over and over.
Yeah, it's a program that'll call itself twice.
Okay.
Yeah. It'll call itself twice, usually in a separate thread, so that you have one, then you've got two, then you've got four, then you've got eight, and eventually it'll consume enough system resources to you'll run out of memory. And there's ways to protect against that on modern systems now, but back then it was enough to crash a computer. And so that was fun. And then in high school, I had a teacher, Jason Parker. I went to Valencia High School for the first 2 years of high school, and that was he was teaching us there a Java class, AP Computer Science, and that was a really great class. He was a really great teacher. He had answers to everything, and he was always right. He'd answered every question we'd asked 100 times before. And there was always like something that you could do to finish the assignment, and then something you could do past that for like extra credit. But it wasn't just like extra credit. It was like he would be really invested in how you solve the problem as opposed to just solving the extra credit problem. And he really got us all thinking about how computers really work on the inside. And now keep in mind, this is in Java even, where you're a Java virtual machine away from bare metal. So really thinking about how objects are stored in memory and all that sort of stuff. And that was really helpful. I ended up actually getting a job right around then as well. I had a contracting job that I had been doing since I was around 13 to 12, 13, somewhere around there.
Wow. So you were making money
company
as a dev. Essentially,
$8 an hour, but yes, I was making money.
Yeah, well, $8 an hour is not bad for a 13-year-old. Like, I grew up in Oklahoma City. I didn't grow up in California, so like, I don't think I had a job that paid more than $8 an hour until I was like 22 or something like that. Like, all my jobs were like less than $8 an hour, but cost of living was obviously a lot lower. But please carry on.
Yeah, so there's a family friend who needed help with something. They were running a small contracting company, and they were just really busy, right? It was two dads that both have large families. We're talking 9, 12 kids each. And
cheaper
they just did. Sorry. Yeah.
Cheaper by the dozen. The Steve Martin movie.
Yeah. They just didn't have time to do some of the more boring things, but for me it was exciting. So one of those was like, they wanted to figure out how can we triple boot Windows, Mac, and Linux on a Mac Mini, right? So I remember I pulled a TV into my garage and had the Mac and a keyboard and all my different flash drives with my different boot ISOs, and I was like trying to figure out, okay, so if I boot and I install Windows first and then Linux into the dual boot partitions for this Mac, that works. But if I do Linux first and then Windows stomps on top of Linux, so then I have to redo Linux again. And I think by the time I ended up handing it to them, it was like quadruple booted between like it had like Ubuntu, and then it had it had Debian, and then it had Linux Mint, and then it also had I think Windows 7 at the time, and then Mac OS whatever version it would have been at the time. And then they also had these small like Python scripts that they would throw over to me and say, hey, can you fix this, or can you make this work, or whatever. And so I did some of that work with them. A lot of soldering and a lot of circuit board assembly as well. And I ended up actually getting my first full-time job from them as well. So when I was a little bit older, their contracting company ended up getting effectively acquired by a small elevator and equipment company that was trying to do some like Skunkworks back of the building IoT program before the word IoT was even coined.
Yeah,
they were trying to do.
Skunkworks is a reference to which contractor was it? It was was it Northern Grumman? It was one of the big contractors, but they like built like this tent out in their parking lot, and they had people work on. I think that's where they developed the supersonic jets.
Yeah.
Yeah, but basically, when you say skunkworks, for anybody who doesn't know what that means, it's essentially when you have your normal company, it's still business as usual, but you got this separate thing out back where you're kind of like doing your moonshot type. Google had like the X project, or I can't remember what it was called, but basically
X Labs, yeah.
X Labs, yeah. So is this where you're doing completely experimental stuff that might come to something or it might not?
Yeah. Yeah,
so an elevator company.
Yeah, so by day they're doing elevator maintenance, and then there's this back room that we had. They hired a whole bunch of college students and then me, and then the two people that ran the contracting company I was with earlier. They hired all of us to build Internet of Things, or IoT, like small embedded circuit boards with onboard Wi-Fi that could connect to, like the Wi-Fi at a CVS or at a Walmart, or we also did personal and private elevators for like retired basketball stars with bad knees and stuff. So like maybe their home Wi-Fi, and it would track how many times the elevator goes up and down. It would track the vibrations. We'd plug directly into the PLC, or I don't know what it actually stands for anymore. We always just called it a PLC, like the main board for the elevator.
Yeah.
The controller, and we would track every little interaction, every metric that we possibly could, collected over time. And this is before machine learning was in the popular landscape that it is today with OpenAI and everything. We were trying to build a model to determine when can we predict with high certainty that your elevator or your escalator or whatever, your load dock, your lift, is going to break before it does, so that we can send a technician out for preventative maintenance, and then you have zero downtime, or you have 15 minutes of downtime as opposed to waiting for us to get there. And so that was a massive undertaking. It was a 4 or 5 year project. They ended up, I don't know if I'm allowed to tell how that story ends, so I'll probably leave that there. But that was my main employment for 3 or 4, maybe 5 years. And then fast forward through.
And while you're fast forwarding, just a couple quick notes. I think you said PLC, programmable logic controller.
Probably. That makes sense.
Yeah, and that's basically like used in industrial automation, so like elevators. Essentially, like it's like a ruggedized, I don't know, but it's designed to be like used extensively for a long period of time and like be, reliable. Essentially, more so than maybe like something that goes into a PC that has like a nice fan and all that stuff. And then the other thing I was going to say is it was not Northrop Grumman, it was Lockheed Martin. The other defense contractor. That's where they had the
other one.
Yeah, the skunkworks. So I just like to not have misinformation on the podcast, and if I say something I'm not sure about it, I'm going to look it up and correct myself. Please carry on. So how old are you at this point?
Oh, not sure. I guess I would have been in high school. Oh no, that job carried me through the first couple of years of college, so it would have been about 20, I guess.
Yeah, and keep in mind the first few years of college. So you did college concurrently with high school. The last 2 years of high school, you were able to also attend community college.
Yeah, so I guess I effectively did 5.5 years of college, because my second half of my junior year and my whole senior year, I also went to a community college. I went to Fullerton Community College, and so I actually graduated early. I believe the beginning of my junior year, I tested out and did the there's like an exam you can take in California to get a diploma equivalent.
GED? Is it that?
Wasn't. I don't think it was the GED.
Okay.
I think you get a GED, but the test that you take is different.
Okay.
I think I do have a GED from that.
Okay. I have a GED too. I just left school and then took the test. It was a lot easier than finishing high school.
Yeah.
But I'm not encouraging people to do that. You can't get scholarships and stuff like that if you have a GED. You generally. But I digress.
Well, I didn't have that issue. I actually got the presidential scholarship at Santa Clara University, so my tuition was covered.
Wow.
With the GED. So
that's great.
I would advise people to do a little bit more looking into that and make sure, because I'm sure it does disqualify you from a lot of them. That wasn't a problem for me specifically. But I also didn't just drop out of high school and then go like take 2 gap years or something. I Oh, okay. Well,
If you want to call living in your car and working at Taco Bell a gap year, sure. It's not like I was
okay,
traveling
all
around
right.
Europe, but yeah.
Yeah. No, my point being, I went to community college for the remaining. So I still did like a 4-year education during high school. I just spent the second half of junior year and all of senior year at a community college, which apparently was the wrong way to do it for other reasons as well. Because in California, with some community colleges, they'll have a program, and my brother and sister did this. So I know from personal experience. You are allowed to attend a community college for free if you are still in high school. The courses are, or maybe it's like $20 or something. It's really cheap or free. I can't remember, and I can't even remember if the $20 was like for meal points or something. And by getting my GED and graduating, I had to pay full price, which for California community college, it's all highly subsidized. It's actually relatively affordable still. I think it's still it's a few $100s.
Yeah.
It's not
Which is nothing in the grand
Yeah.
scheme of things if you're unfamiliar with the cost of U.S. higher education.
Yes.
California has something called the Master Plan, I believe is what it's called, and it's essentially like they created all these community colleges, and there's like basically the best community colleges on earth, and they're also incredibly affordable. If you're looking for affordable education, my humble advice would be go get California residence and send your kids
Yeah.
to California Community College, and then see if they can, transition from community college to a good, research institution like you attended, or a California State University. Schools those are great too. But like California's got just like chef's kiss, like best higher ed you can get basically, and a lot of it's public.
Yeah, the community college that I went to was great. Yeah, and again, especially considering the price, it was great. And they also had all sorts of community events. So one other thing that I went to is before I even started my computer science class, even in high school, there was an event that they were offering. It was led by Llewellyn Falco, if you know that name. He was one of the he was an engineer at Google for a while. He was one of the Google Glass ambassadors back when those first came out, their augmented reality glasses. And he did like an intro class to computer science. I was actually in between chemistry and computer science at that point. I wasn't sure which path I was going to take, and that helped kind of solidify and push me towards computer science. And then high school kind of crystallized it completely. And that was all offered through the community college. And I think that was like $5 to join. It was like a registration fee or something like that, or $5. So yeah, and then in college, I ended up, after the work with that elevator company kind of shut down for me, I ended up getting a job with a company called CellPoint Systems, which is actually my current employer right now. And that might be confusing because we spoke ahead of the call and I mentioned a few different things.
Yeah.
I have a lot of irons in the fire. So my primary employment is with a company called CellPoint Systems, and we had a large contract with a FANG company that has a lot of love for the Go programming language. So in order to help kind of secure that contract, we promised them we would write everything in Go. That ended up being how I got introduced to Go. So I guess I'm more of a relatively recent convert, only about 6 or 7 years, maybe 8 years of Go.
Yeah.
Yeah, so we started using Go. We started using Go before there was a Go package manager, like the Go module system didn't exist yet. So it was really rough when we first started, but it came out almost immediately right after I started writing Go. So that was very nice. That's been probably the best thing that they've added to Go, is the package management is really, really good. Especially because you don't have to have a registry, you don't have to have anything, you don't have to like use pip or have like the npm registry or JSR or any of the other, that's the JavaScript registry that's tied in with Dino. You just have a Git repo with a public URL. Congratulations. If you tag your Git commit with a tagged numerical release like v1.1.1 or 1.1.2, and you have a public Golang package that can be used and imported by anybody. That I think is one of the strongest points of Go's ecosystem right now. So it's gotten a lot better since I started working there, but that was kind of my introduction, is when I started work at CellPoint Systems. over time, that contract grew and expanded and grew and expanded. We grew the team. It was initially just a couple of us. It blew out to maybe 8 or 10 of us at the largest point, including all the hardware and the software engineers. And then I ended up leading that team over time. The head of that team started becoming busy with other things, and I ended up taking over the team. And I ran that project for several years. The contract finally came to an end. We had renewed it like 3 times, and then it's finally like, okay, there's no need for renewal anymore. That project kind of came to an end. And then the president of the company, it's a very, very small company, first of all. We're at most 20 people and usually around 6 or 7, I think. The president of the company, his name is Rich, is because it's such a small company, he's my boss. He's the owner of the company, but he's my boss, but he's also like kind of like my friend. And so he and I got to talking. We started having some ideas about some of the pain points that we had during this contract with the Fang company. And a large part of that was due to SaltStack.
Yeah.
SaltStack
And
is a
you've written
great
an
program.
article basically like breaking up with SaltStack.
Yes.
And you
Yeah,
use
exactly.
that no longer best friends with meme.
Yeah. So I won't go into full details there. If you want to read about
I'll
the
link to
beginnings of Garlic, yeah, he'll put a link to my blog. But I was introduced first to SaltStack at that equipment and elevator company, and kind of brought it with me all the way through to the through the role that I had at Cellpoint. And there was just one thing after another. There was like a major critical vulnerability that, in my opinion, was not addressed properly. And then we were getting crashes at runtime due to high memory usage and a bunch of other things. I was talking to Rich, and we're like, well, it would be really nice if we could solve some of these problems, because I'm sure we're not the only ones having them. SaltStack is used everywhere. I think all four of the old Fang companies, four of them, were using SaltStack, and then a bunch of other Fortune 100 companies are all using it. Fortune 500 are all using SaltStack. So like, well, we can probably address this problem, and then to drag it back to the beginning of our conversation, bring it from an interpreted language like Python, which that's what SaltStack was written in, to a compiled language like Go. And it'll take a little longer to write it initially. It'll take a little longer to compile it at build time. Fine. But the end result is we get a single binary that can be just dropped onto a system without having to use apt or RPM to install a whole library of packages and dependencies at runtime. So when you're dealing with something as important as rolling out servers and making sure that all of your developer operations and everything is all like solid, and when I hit deploy, it actually deploys and it goes out and we have a server spun up. The fact that you have to install 30 some odd dependencies alongside SaltStack to get SaltStack up and running, and then do configuration of it, as opposed to just dropping a binary, dropping a systemd service file and saying systemctl start and just having it run. There's a clear advantage to using a static, like a precompiled static binary.
Yeah,
like
so
Go.
it's just getting things live faster and like not having to worry about those dependencies. Dependencies do break sometimes. And if you're like,
in our experience, they broke all the time in production. And a lot of these devices that we're dealing with are on cellular connections in a remote desert. And now we're just hosed. So we can't deal with that. We need something that's going to be stable. And you have a trade-off between, am I going to turn auto update on all these remote systems so that we get security updates from Ubuntu or from Canonical,
because that can bring it down too,
and then lose the stability? Or do we just stay vulnerable, and then we only do like patched updates when we know that they're tested? And the problem is when you have a lot of devices that have to operate in the field and they remain connected to the network, but that network may lose connection to the internet. For example, like in a retail store environment or something like that, you're still susceptible to incoming attacks on that store network. You got customers connecting to the Wi-Fi, but you don't have the ability to auto update or push controlled updates at a set time.
Yeah.
So your best bet is going to be auto update then to maintain security, but then you lose stability. So it's all these different trade-offs and stuff, and I really wanted to avoid that. So that's part of the main thing behind Garlic.
Okay, so Garlic, spelled GRLX. Basically, the reason for it to be is you can have a binary that you can just drop onto a system, And then when you need to do some sort of security patch update or something like that, you're not actually going in and running a bunch of procedures. You're just essentially flashing that with the latest dump of the binary.
Yeah,
Is
you
that
just have a recipe file, and the commands are streamed down from a control server down to the target device or devices. It's meant to be used in a fleet. Fleet being the word that's kind of taken from like enterprise rent a car, like other like fleet
Yeah.
vehicles, right? You got a
Yeah.
fleet of devices, and you are pushing out a change to either all or a subset, or like an A/B test group. You push out a recipe change to some set of devices, and that set can be all of them or just half of them or a couple of them.
Okay, that makes a ton of sense. So I can like just I think you created a very cogent argument for why what you're doing is so much better than the old SaltStack approach. First of all, the fact that it was written in Python, we already talked about like the performance trade-offs of having it written in Python. If it's written in Go and like you're actually doing everything, and then it doesn't even really matter what happens prior to preparing that that binary that you're putting out there. It's just that the binary does run, and you can be sure that the binary runs and that it's secure and everything like that before you. Well, I mean, you can't be sure that everything's secure, but to the extent that you can be sure, you can have it ready to go, and then you just deploy it out to your fleet. And as you said, some of these could be like a freaking cell phone, CDMA, or whatever.
Smartwatch, yeah,
yeah, like devices with low power, with low connectivity. Where you can't necessarily control all the different circumstances, but you can get this out there, and it's just like a much more sensible way of doing it than having to. And so it sounds like those are the main reasons for using something like this. So this is the open source project that you maintain, and my understanding is it's essentially sponsored. Development is partially sponsored by the company that you co-own, and then it's also you have a few organizations using it and people that donate.
Yeah. So there's some of the more popular or some of the companies that are interested in having their names on our README are in our README. So we've got a couple of data centers, I think, in France, and then I think Google is using it, and a couple other companies are using Garlic. It is maintained officially by Adatomic Inc., which is the company that I mentioned earlier. I co-founded with Rich, the owner of Cellpoint Systems.
Yeah.
And so we have corporate backing in that sense. That tends to make people feel a lot better. The people that are making the decisions for switching a DevOps platform from something like SaltStack are going to want to see that like Garlic isn't going to just disappear overnight or go away. The other really nice thing in my humble opinion about Garlic is that we've zero BSD licensed, which is a massive sticking point for a lot of FANG companies. I know that Google has like a policy that you're not allowed to use any open source software in your code.
The GPL
that is not written by Google, that doesn't have approval from the legal team.
Okay. So
and GPL is out the door immediately. AGPL out the door immediately. MIT software still requires approval within Google.
Really? MIT is considered like
MIT.
I always consider that to be like basically the gold standard of openness, and we use BSD 3.
Yeah.
So you're using BSD 0?
Yeah. So we're using zero BSD. So and I just want to be clear. They'll usually approve it if it's MIT, but it does still require approval.
But what about BSD 0? Zero BSD, does that require approval?
No, it does not at all. That's the reason why I ended up going with it, is because zero BSD takes away the only clause that the only two clauses that are in the BSD license. So basically it just says like, here's some software. You can take it, you can even rename it, you can remove the attribution to all the authors, you can do anything you want with it. Here's some software, have fun with it.
There's literally no restrictions.
No restrictions whatsoever. Like, don't sue me.
Basically, we just don't want people to like. Oh, okay. So it's just don't. I'm not going to be held liable.
Like I say, don't.
That's
sue
the reason
me,
for using this as not having any sort of license.
I do maintain.
Yeah. Go ahead.
Yeah, and I do maintain copyright over the word garlic and over the mascot. We got a mascot named Clove. I'm actually wearing him on my shirt right now.
So it's like a gopher with like just verbally describing it. It looks like a clove of garlic.
Yep, it's clove of garlic with the gopher eyeballs and nose and mouth. So yeah, I maintain copyright over garlic and over the mascot clove, but otherwise the code base is 0 BSD, and it's not really because I want people to take the code base and run with it and like rename it and then go make $1 million off of it. Like if you do, please send me a check. But it's more just to get over that legal hurdle,
Yeah, I mean, that makes
and
great
make
sense.
adoption easier. Yeah,
Yeah.
because my main customers are going to be people that have fleets of devices. That's not going to be like users, right? It's going to be companies that are making a decision on, do we go with this system or that system for tens of thousands of devices? Because that's where garlic really shines. So if that's my audience, I need to make sure that I'm not introducing additional legal hurdles for them. Now, if you want support, like a service contract, you want support, then you can pay money for that. That's part of the reason why we have Atomic.
Yeah.
Is we can sign contracts through Atomic for windows of time that you want allocated to you, response time, all that sort of stuff. If you want us on call, and then additionally, Garlic is shipping a plugin system, so Garlic by default requires no plugins and requires no dependencies. That's like a huge selling point of it. But there does come a case where building everything into the main binary will increase the bloat of the binary unnecessarily for people that don't need all those features. So we have in the works a WASM plugin or WebAssembly plugin system that allows you to do things like connect to an LDAP server, or connect to allow you to do more fine-grained role-based access control rather than just users and groups, which is built in. If you need to hit like a certain storage backend, like we built in, we support pulling files from S3, we support pulling files from FTP, from SFTP, we support pulling files from all these different backends, HTTPS, FTP. But if you need to pull it from like a Google Drive, okay, that's going to be a plugin, because that's not something that most people are doing in their deployments.
So essentially, like you'll build plugins for hire.
Yeah. So
like people can give you a bounty, like they can be like, hey, I would love for this to have Google Drive integration, and then you can be like, sure,
exactly,
I can make that happen.
So we offer that as well.
Essentially, like offset me for the development cost.
Yep, yeah. Exactly. So those are our two monetization strategies: are the service contracts for support, and then feature prioritization on the plugins. So we're mostly focusing on WASM. I've been doing some exploration recently on Shopify has a Golang implementation of Lua. So adding like a Lua plugin runtime as well. But that's not promised yet. That's not really on the roadmap yet, but I've just been evaluating it to see if it's worth doing.
Okay, so what I'd like to do is kind of generalize out the advice that you have here, how you've approached this. So if I can make some observations. One, basically do everything to simplify adoption by, the kinds of companies, like if you're doing like fleet, computing. I can't remember the exact term you used, but essentially just like huge arrays of different devices that are maybe really small devices that don't necessarily have like a whole lot of onboard memory or onboard storage or something like that, where just having it be extremely efficient is really important. Yeah, like I know you said the company that you work for has like cell in the name of it. It's like a cell phone tower type company or something related to cellular.
It comes from that, yes.
Yeah.
Initially, yeah.
So like would like a huge kind of like fleet of cell towers, and would that be like a potential use case, or like CubeSats, or like what kind of devices are we talking about when we talk about fleet devices? Internet of Things.
We're talking like mini PCs and display controllers for the most part, in terms of Internet of Things. But Garlic is not really geared specifically towards IoT. It will work really well with that use case because that's my main background. But I also have a large background in doing cloud VM server deploys. And actually just behind this door here, I don't know if I could open it, but I've got a giant baker's rack full of just Intel NUCs, just like rows and rows of them that I do stress testing on for
Very
Garlic.
cool.
So we have yeah, I'm running probably 35, 40 different machines
You
just on
said
the
I
other
don't
side of
know
the
if I can
store.
open it. Could you try I'd love to see it. And
Why don't we hold that for the end and we could show it
oh,
later
okay,
because I don't
yeah.
want
So
to
stay to the
edit
end
it out.
if you're watching the
Yeah.
video version. If you're watching the audio version, I'm going to verbally display, share everything that I'm seeing. So, just to finish what I was recapping before I went off on that digression of use cases like who use this, but essentially using the zero BSD license to make it really simple for Google and other big tech companies to adopt without having to take up their lawyers' time, getting clearance. Making sure that it's totally free, totally open source, that people can do whatever the heck they want with it. But the goal is not to sell the software. The goal is to sell services that support the software in the sense of feature prioritization and in terms of actual contracted support. A lot of people do not want to just grab some tool off the shelf and not have any support and essentially rely on their own engineering team to go and debug and fix things. They want to have the actual people who built it who can help ensure that everything's going smoothly, and that's where service agreements come in.
Yep.
That is what you are essentially doing is free open source software that has dimensions that make it sustainable. You're not doing this out of the goodness of your own heart necessarily. Obviously, you're probably doing that. That's a big part of it, but you're also wanting this to be a sustainable long-term operation. So you kind of bake that into the proverbial business model of this open source endeavor.
Yeah, exactly. I mean, it's going to be a while before it's something that can be sustainable on its own. Rich and I have put a considerable chunk of money into it, not just into not ignoring my development time completely. And I think GRLX been around how long now? I don't even know. It's been
5
at least 3 years, maybe.
Yeah,
it's been years. I don't know when version 1 was officially published. Version 1 might have only been published 3 or 4 years ago, or the first public commits. But it's been in the works for 4 or 5 years. And then we've spent money on marketing, T-shirts, conferences, all sorts of stuff, trying to meet with people that are in the right space on this. And I would say that's probably where we've had the most success. Is we go to, or at least I go to GitHub Universe every year. And I go and I meet with the vendors, and it's really important to be respectful of their time because they're there to sell other people on stuff, and then I'm trying to sell the people that are paid money to sell stuff. So it's more just like a quick introduction and hey, can I talk to you later? I'm not going to pitch it right now. I'm going to talk to them and say, hey, I've got something that would work really well with your service. Can we set aside some time to talk about this when you're not on the floor right now talking to other people? Because they paid money for their ticket too.
Yeah,
you got to be respectful.
It costs a lot to have a booth.
Oh yeah,
and to be an exhibitor costs money, and you're there to.
You should know, right? Haven't you had one with freeCodeCamp a couple times or no?
We always get, because we're a charity, they'll just give us
them for free.
Yeah, but we're not trying to sell anything. We're just raising awareness of the various open source endeavors within freeCodeCamp. But okay, so that's useful, actionable kind of sales advice. Don't be mindful of the fact that those people are there with a different mission, and just kind of step in, introduce yourself, and then that's a warm contact. When you follow up later, they're gonna be like, oh yeah, I'm that guy that dropped by, and here's what I was talking about here. Or can we meet and grab lunch, after the exhibition hall closes or something like that? Or I guess it wouldn't be lunch, but how do you I guess a lot of these companies are in the Bay Area, so it's not you're in the Bay Area, so it's not out of the ordinary for you to drive or take the BART or something to Caltrain to go meet up with somebody in San Bruno or something like that, wherever they happen to be.
Yeah, I mean, I've actually been doing a lot of it over the phone. I've had better success with that than driving out to meet with people in person. And I think part of that is just, for the types of partnerships that I've been going after, people have really seen it as more of a partnership than either one of us selling the other on something. I mean, it's been good for everybody on both sides, because I can look at it in terms of okay, well, maybe I'm not going to get a service contract out of this, but I've got another user and I've got someone else who's excited about this because it's an exciting project.
So you got kind of a range of possible outcomes, and just getting a user is still a win. Getting a service contract would be the best potential outcome.
Yes, I mean when I get another user, because of what this software is and what its role is, a user isn't one computer running Garlic. It's going to be hundreds or thousands. So the number of compute minutes that Garlic is running on different services, I mean, ideally it's low per system because I'm trying to maintain, low resource usage and everything. But the number of runtime hours that Garlic gets, I see that as a nice metric to go for. And being zero BSD, I have no telemetry, so I rely on people to tell me that they're using Garlic before I know. There's a community Discord, and it's people start pouring in and saying, "Hey, I've been trying it out. I like it. I don't like it. Here's what I don't like. Here's what I do like." And then we take the advice under take the advice under consideration. There's no telemetry or anything though, so other than on the Garlic website, like the docs page has like a post hog integration or something. So I do see people that are visiting the docs, but the binary itself doesn't do anything like that. So yeah, I mean, there's plenty of things that would get me excited if someone's just using it. That's nice. Service contract, of course. I'm not going to say no to money, but yeah, I really want to get Garlic to become like I guess household name is the wrong terminology, but
because it is
like
a very
household
specific
name.
industrial tool. It's
Yeah,
like
yeah.
like I don't know, like CUDA isn't necessarily like a household name, but it's very important.
Yeah, so I want to take on the market share of Salt Stack, Ansible, Puppet, and Chef. Like I want the list to be Salt Stack, Ansible, Puppet, Chef, Garlic. Like I want, and who cares what the order is, but I want to be on that list with everyone else.
Win. So
yeah,
even being in that room is an accomplishment in itself. Okay, that is helpful context. I want to talk a little bit about your consultancy and like how you've been training junior devs and essentially prepping them to ramp them out to do client work. Can you talk about that a little bit? Because I think a lot of people are going to be interested. First of all, a lot of people listening to this would like to enter the market as devs. And I must say you're in the right place. This is precisely the kind of thing you should be doing with your time if you want to become a dev, is learning from people like Tai Groot, who've been out there in the proverbial mines, getting things, bringing things up to the surface. Can you talk about that kind of approach that you have discovered over time and like what you've learned from bringing people on, teaching them, and getting them ready to work with clients?
Yeah. So in addition to Cellpoint Systems and Atatomic Inc., I also have my own single member LLC. It's called Tiger LLC. I ended up filing an LLC primarily just so that I could get an office building, so I'd have a place to really focus and work. It's like one city over from where I live. It's not too bad of a drive. It's like 10 minutes. And I just wanted like a space to get like I have tons and tons of equipment here. I've got like 3D printers and multiple machines, and like I said, a baker's rack in the back with a couple dozen systems. So I filed an LLC just so I could get like a I don't want to call it like a creative space and sound like like all hoity-toity and everything, but like I need some place that I can sit down and like this is the place for work. And so I filed an LLC, and then not long after that, a friend of mine, his name is Scott. He and I work with a lot of the same clients. Just consult. I was consulting as an individual before that, but he and I were working with a lot of the same clients. And we kind of realized like there's a lot of work here that isn't necessarily boring work, but it also doesn't require us to be firing on all cylinders just to get it done. So it's not really like tedium, but it takes a long time, and we're using maybe 30% of our our capacity as developers to build some of these features that we need. So we started looking for like, okay, is there anybody that we know that we could kind of hire for this role? And the answer was like, yes. Live in the Bay Area. Everyone here writes code. Not really, but it feels like that sometimes.
Yeah, I mean, when you walk into a cafe, everybody's got freaking VS Code.
Yeah, you're at a bar and someone's got that. That's me half the time, so I should pay attention to who's talking. But yeah, you walk into a bar and there's a split keyboard out. But it's like, okay, well, everyone here, writes code or knows something about code, or could potentially fill the role that we're looking for. The problem is the cost of living here is super high, and a lot of our clients aren't here. Like, so they don't have that cost of living baked into all their expenses. They're not expecting to spend as much on a developer. They're not expecting to hire somebody at 250, 280, $300,000 a year. They want to hire somebody or get work for somebody at an hourly rate that would convert to something closer to 70, 80, 90. And that's not a bad wage, right?
Yeah, not outside the U.S. In California, it would be pretty difficult to live on that. But
California, it's tough. Yeah.
Yeah, in the U.S., like where I grew up, Oklahoma City, that would be like perfectly respectable. Like you'd be like pretty well off if you could make like $80K a year. But then if you go overseas to Europe, or to Asia, or to Africa, like suddenly you're like the richest person you know, basically, with a wage like that in some places.
Yeah, so that kind of made me shift our focus to like, okay, we can hire somebody, but then the client wouldn't be able to afford them, and they already can't afford us. Like, there's stuff that they want to do, but they're like, oh, but maybe we'll do it later. Like, we can't really afford to do that right now. That's the kind of situation we're working with as well. So we're like, okay, instead of hiring somebody from the Bay Area, maybe we can, expand our horizons a little bit, not look for somebody here, and instead we'll look for somebody that's, somewhere else in the United States. So the first contractor that I brought on is actually from, let's say, Central Time Zone, right?
Okay.
So south of Kansas and Central Time Zone. We'll put it like that.
Okay.
And she's somebody that I knew in childhood, and she's was in that same computer science class with Jason Parker that I took in high school. She was a year ahead of me, but she was in the same class. So I kind of knew that she would probably have a somewhat similar background to me on some things. We were on a robotics team together in high school as well. So I knew she kind of had a mind for problem solving and for asking questions. And that for me, I don't think I'm being original when I say this, but I think that for me is the most important thing, is not what you know today. It's more your mind for asking questions and learning new things and figuring out the right way to do something.
I'll co-sign that.
So
that has been my experience
way more important than how many years you've been writing a language. Because the person who is interested in learning the tooling, learning how to do something correctly, and constantly asking those questions and upskilling, is going to be able to pick up a language faster than, like, pick up a brand new language and be better than you at it than someone who's been writing it for, writing the same language for 5-10 years. Because it's like a mental and like a personal evolution over time. You just keep upskilling and getting better.
Acceleration overtakes speed.
Yeah, absolutely.
That doesn't actually make any sense, but that's what I mean. Like, if somebody's going like way up here and you're going like this, you will eventually overtake them if you're working on it.
Higher order derivatives for the win. Yes.
Yeah.
So I reached out to her and asked, like, hey, what are you doing these days? Are you like, where's your work? Oh, I just finished school. Oh, was it a computer science degree? No, it wasn't. It was, I think wouldn't mind if I say I haven't said her name or anything. So she actually graduated and finished school, pursuing a nursing degree. She had some electives that she had done for networking and database management and a couple other things, because that was always an interest, but that wasn't the degree. Those were just like electives, as far as I'm aware. And so I ended up saying, hey, well, what's your job prospectus, where you're at? And she kind of talked to me a little bit about that. And I was like, okay, what if I paid you double that? And what if you could start working with me like next week? I've got a client that has such and such budget. And I shared all the numbers with her. I was very open on like what the client could afford, what the client could pay, what I would keep in the middle, all that sort of stuff. I try to do that with everybody that I bring on.
Yeah, that's really chill. I think that's a good, because then you don't ever have to worry about them finding out. Oh, like, or like cutting you out.
Yeah,
That's
exactly.
another thing is that you have to worry about when you're kind of like a middle man, for lack of a better word.
Yeah. Yeah, exactly. And I've dealt with that at another company in the past, but that's a side story for later. So I said, okay, great. She was up for it. Said we would give it a try. Great. And I said, okay, here's the thing. You've not written code professionally ever, and you've not actually this will also be like her first like real job outside of whatever she might have done in high school that I don't know about, right? So I was like, okay, here's what we got to do. Before I feel comfortable handing you over to a client and saying she's going to bill out at this rate, get these things done, go for it, and then just kind of like leaving her to be, like leave her to the wolves. Um, I actually spent the first 3 months bringing her on, going through all sorts of onboarding and training. And so what that meant for us was I wasn't exactly sure which projects the client was going to prioritize. And like any end customer, they're going to need front end and back end code. Like you can't have a company these days without having a website, really. And they're selling online courses, so that's like a huge part of their business is their website, right? Um, there's also a massive part that's to the back end, like tracking registrations and who's coming and going and which classes are you taking, which classes get canceled, are we sending out transactional emails correctly, all that sort of stuff. There's like a massive back end to this as well, and a headless CRM interface, all sorts of other customer relationship management, and a CMS, a content management system as well. So we've got all these different like bits and pieces that are built and running in the back end, and then we're told by the client that they have these tasks and jobs that they want done that they can't afford to pay us at our current rate. So I am now in the position where I have a developer that can make this the correct rate that the client's willing to pay, but I don't really know what their priorities are because they didn't tell me yet, because in their minds they can't afford anything. So I ended up training her full stack. We went front end, back end. We did data transfer back and forth. We built a small little app called Bridge Time, which will probably spike in traffic after this, which is just for like if you've got a friend who said, oh, just if we have one of our mutual friends is very macabre in his sense of humor, and he said, if I ever forget how to tie my shoes, I just want you to put me in a wheelchair and huck me over the side of the Golden Gate Bridge. So we made Bridge Time based on that. It's like you can put in like if someone breaks a promise or says that they wanted to do something or whatever, that type of agreement, it's like a joke. Then you send them the link when they do the thing, and there's like this little animation that plays of a guy wheeling someone over his side of it. It's all pixel art. It's not graphic or anything. It's just funny. So that was a joke site that I wanted to do for a while. So as part of our onboarding, I actually sent her a whole bunch of freeCodeCamp videos from the React track. They're some of the older videos now. I think you guys have reshot a couple of them. I saw one of them came out again 7 months ago.
Yeah.
This would have been a while before that. And basically gave her a starting point where she could work on. And that was a really good foundation for her front end track. And then from there, I kind of brought in some of my knowledge and some of my expertise using, Next.js and a couple of other, more meta frameworks for React. Basically said, okay, the freeCodeCamp video shows vanilla React. Here are the different things that you have to change to apply this to a Next.js code base. And then we kind of carried on from there, and she built the front end for that. And then we moved on, and she actually took some courses. I paid for her to go through boot.dev, which I know you're familiar with them as well.
Yeah, I've had the credit one.
Yeah, and I'm friends with Lane Wagner as well. I don't know if you would call us friends. I'm acquaintances with Lane Wagner. And I sent her through the Go backend course, and then she kind of filled in some other backend stuff as well. And then we built a backend in Go using just SQLite hosted on a $5 VPS. So that whole site, she built everything there. I made some tweaks and changes and kind of gave her advice and nudged her along. But basically, I used some of these resources, and she's also, like I said, a very self-driven person, and that's the most important thing to me, is that you are willing to put in the work, and that I'm more than happy to lend a helping hand and point you in the right direction towards the right tools. That was the first person that I contracted with. I've got a second and a third person that are kind of going through the exact same thing. The third person, we're actually giving him some assessments and tests right now. He's out of Poland. And so, yeah, just kind of trying to slowly build this up over time, and bring different people in.
So you're not just going out there and trying to find talent that's already on the market. You're actually bringing new talent on the market, and you're also helping kind of like nurture that talent and provide guidance. Like you mentioned, like here, build this project, here, take this course. And so you're kind of giving them like a curriculum that you think is best suited to whatever the work that you have on hand that needs to be done, because you have kind of like this lead time in terms of your client's going to want this. And at this point, you find somebody, you're like, I think this person can do it. Like, I think they have kind of the raw input that's necessary in terms of like the curiosity, the problem solving skills. They have enough exposure to, programming and, software development concepts that I think that within whatever period of time that you have available, you will be able to get them up to speed. And you actually put your money where your mouth is. My understanding is it does cost some money to pay people essentially to learn and give them kind of like a paid internship almost, or a paid apprenticeship, if you want to call it that.
Yeah. It's probably 3 months of full-time pay, that I'm not actually billing a client for that time. Right. And then in addition, I also, we use pull requests for everything.
Yeah.
It's all of our developments through GitHub. So every code, every piece of code that comes through, I end up reviewing it before we merge it for the client, cause they're a real business. They want high uptime, right? If the site goes down, people can't purchase things, they're losing money. So they need to have good uptime on everything.
Yeah.
And part of that's the tools we choose. We're using like a durable job system. I think we're using Temporal for a couple of different things. And then part of it is just the code review aspect too. And it's gotten easier and easier for me working with the contractors over time, because, when I know what a certain change is going to entail, I can just kind of give it a quick glance and say, yep, that looks basically about what I would expect. And I can just merge it. And then, for some of the newer features, I was up till midnight or 1 a.m. last night working on something for a new feature that was kind of out of the general realm. We were trying to get a Postgres database dump built into a DigitalOcean app platform worker, and it turns out it's not possible. But I had to prove it wasn't possible, and that took many hours first. So anyway, at least not in the way that we were trying to do it. So
yeah. Well, it sounds like between your consultancy work, Adam. What is the name of it again? It's Adatomic.
So my LLC is Tiger LLC, Adatomic Inc., and then Cellpoint Systems.
Okay, and Cellpoint's your full-time employer,
Yes.
And then Tiger is your own personal consultancy, and then you're co-owner of Adatonic. And I just wanted to share this word because I didn't know what it meant. I was like, what does that mean? So adduction is where something doesn't get like absorbed or adsorbed. I don't know the term. I'm not a physicist, but essentially you can like an atom maybe resting on a surface and not be like absorbed into it like a fluid. And so that atom sitting on top of that surface is kind of like poking out, essentially protruding at like an atomic level. So it's a very minor protrusion, but essentially that's what adatonic means. It means kind of like adhered to or stuck to something else.
Yep. My chemistry background from that I almost went down that track coming back here at the last moment, right?
Yeah, very cool. So you got to open the door. I want to see what's behind there.
All right, we'll see, but we can't. We might have to cut it. I don't know what the camera will be able to see back there. So,
okay,
all right,
let's try.
see.
So
We go to the other side.
I will narrate. We can't. Ty's not near the mic, so he's not going to be able to say what he's doing here. But essentially, he's gotten up out of the seat, and I want to remind you, we don't edit this podcast. This is unedited, so I'm just filling dead air here. I'm not going to attempt to tell a joke or anything. Looks like he's opening the door. The door is opening. It's a big wooden door. I can hear things being moved around. The door is opening. Whoa! Okay, so he's moving his chair. Wow, I can see. So I see a bunch of racks, and I see a lot of Cat5 cable. It looks like,
Yeah, the screen is not capturing everything. There's another two or three racks above the
There are
border
two
of
or
the
three
screen
racks
here. But
above. But imagine like if you watched it like Die Hard with a Vengeance, like the bomb scene where they're defusing the bomb. Like that's basically what it looks like back there. Just a whole bunch of cabling and a whole bunch of small devices linked together. But that was very cool. Thank you for opening that door, Ty. Now
Yeah.
everybody who's curious about what's behind that door, you can't
What's
show
behind door
somebody a
number
door and
one?
not open it, right?
Yeah.
Yeah. Awesome, man. Well, it's been an absolute blast learning from you, talking for you for the past 2 hours. I learned a tremendous amount about the various trade-offs associated with those different programming languages: Go, Rust, TypeScript. I learned a lot about the Linux kernel that I didn't know in terms of just how, like, I guess, tight it is in terms of like the extreme requirements that people have for code that gets submitted, and also at the same time I didn't realize that like device drivers were just dropping huge blobs of C code from the air, and then they were having to get merged in, and it's kind of like, yeah, like the distribution of, I guess, accountability for different things in that world. But it's so cool to talk to somebody who's in the open source world, who's like touching on so many of those different things. What is some parting wisdom that you have for people who've made it this far into this podcast in terms of people who would like to ultimately do what you're doing like the hardcore back-end development, working with maybe like underpowered hardware, huge fleets of devices, and being able to essentially get as much runtime on as many devices as possible if that's the metric they want to optimize for? What should they do?
This is going to sound silly because it sounds like I'm just copying the meme, but seriously, use Arch Linux for real. And don't go through the new Arch install script installer. Like, it's really important to understand how all of your system works, like top down. There's plenty of YouTube videos out there now, tons of educational material on how Linux works. I've built a Linux from scratch system. Everything sounds much harder and much more complicated than it really is. Linux is not hard. I've got working audio on Linux. This whole podcast has been recorded on working audio drivers on Linux.
Wow.
It's audio and video, right? I think out of everything that I've done, the fact that I'm running a daily driver computer that breaks on me once every few months is actually what's driven me to figure out why things break and figure out the real fix as opposed to a Band-Aid fix on top of something. So the number one thing is, and Arch Linux is kind of a joke, but like, dig into how your computer actually works. Figure out what's actually going on, either when you write code or when you click a button, like everything from writing code to clicking a button. Figure out what you're doing is actually doing on the CPU, what it's doing in memory, and what it's doing on your file system. That's, I think, the most important thing. To understand things at a higher level is understanding them also at a lower level.
Awesome. What a great note to end on. I'll just mention that we do have an Arch Linux handbook that was published by Farhan Chowdhury, who's a prolific FreeCodeCamp contributor. You can check that out if you're just looking for a good Arch Linux starting point. So just like grab some random PC that you haven't used in a while and install Arch on it. I mean, is that like that?
Yeah, and even if you don't use Arch Linux, the Arch Wiki is still one of the best sources of information. The Arch Wiki, and I've heard the same of the Gentoo Wiki, but the Arch Wiki will almost always have like an answer or someone else who's had that same problem that you have, even if you're using Ubuntu or Fedora or something. Like the Arch Wiki is really, really good.
Awesome. Well, everybody out there, I hope you have a blast learning more about Linux, learning more about the actual hardware and the various layers of abstraction underneath all the code that most people are writing. And I urge you to also follow Ty's advice there. Ty, it's been such a pleasure talking with you, learning from you. Really appreciate you coming on, man.
Yeah, thank you. I appreciate the time. Anyone who's interested in who I am or what I have to say, I've got my blog at blog.tiger.com. You can also just find it on my website. I've got a GitHub, which is at Tiger, TAIGRR. And on Twitter or X, I am WarpTux, spelled WARPTUX.
Awesome.
Yep.
And Tux being, of course, Tux
the Linux
Penguin.
Tux, yes.
Yeah. Very cool.
Yes.
Well, everybody tuning in. Until next week, happy coding.